Hello, everyone. Welcome to my channel. Happy Tuesday. I am going to be working on my board doing an applications again today. And so I'll go ahead and get into it. I hope everybody's doing well. And yeah, Tuesday, good day to do some math. All right. So what I did was I dug through some of the problems that I found a file that had some problems that whenever I taught trig, and I had some examples that I worked out, and I came across those, and I was like, cool. So I'm going to use one of those. It's a bearing problem, and I said again. It's a bearing problem, and you can use it's a triangle application, and you're welcome to use law of sines. However, sometimes law of cosines is more practical depending on what values you're looking for. I would say if you're looking for an angle and you only have one angle to find, or two angles to find rather, law of sines might be better. But if you have two side lengths, you have an angle known, it might be better to use law of cosines. So here we go with, we'll call this trigonometry. Applications. And start to marker out. Okay. All right, so in this problem, it's a bearing problem, and it says a ship leaves a port and travels on a bearing of north 40 degrees east. For 11.2 miles. Okay. And then it says the ship then turns due east. And travels for another, I believe it's 3.3 miles. How far is the ship from the port? And if this problem was involving right triangles, it would be a lot simpler because we could just use the Pythagorean theorem. However, this is an obtuse triangle where it does not contain a right angle. Oh, what am I doing? Drawing a triangle. We have a bearing problem. My oh, epic fail. All right, I need that. So I have to draw my coordinate system for the bearings because the bearing is a direction and the compass is laid out like this, where the positive direction is east, negative direction is west, negative direction south, and positive direction north. And bearing is from the y-axis. So if you have a north bearing, you're going to be traveling whether it's east or west. And if you have a south bearing, you would be traveling west or east. So this problem says north 40 degrees east. So bearing is always out of the north. So you're going to find a 40-degree angle and draw your bearing. So this is 40 degrees. Draw it a little bit smaller. So if a ship leaves a port, we'll say the origin is the port, and it's going to leave this port and it's going to travel 11.2 miles. This is how we're going to draw the triangle. It says, then the ship turns due east and travels for another 3.3 miles. So due east is, I would just draw a horizontal line due east, and then this one is going to be 3.3 miles. Let's see, maybe I should get my ruler. I can probably wing it, but I like to use this thing. So we have this triangle essentially. So it's asking for that third leg if it's asking for the distance from the port. So it's looking for this distance right here. We'll call it X. All right. So now I'm going to draw the triangle, and we can just put it here to kind of condense. I'm trying to be more organized with my board. So A, B, C, little a, little b, and little c. You know, I should probably go ahead and not be lazy and make that look like it a little bit more. So I apologize for putting y'all through that, but hindsight, I kind of just have this triangle laid out. And try to draw it kind of more to scale. Of course, I don't have the ruler anymore. All right, I think this will do. So, all right, so I think that's good enough. Got that angle, got that angle, and this angle. And so we'll call this the distance 11.2. This is the distance 3.3. And you're just looking for that distance right there. We have to find one of the angles in the triangle. So that's pretty much the key to solving this problem. And so we're looking at this right here, and we're remembering, let's see, we got 40 degrees here. Let's see how we can do this. And so I will actually make that a little bit connected. Again, this is just me practicing. All right. So if I make this one right here a right angle, then that's 90 plus 40. So I have 90 plus 40 is 130. And then so I have to subtract from 180, 130, and I get 50 degrees. Okay. Also, if I knew that 40 and 50 make 90, then I can also just say that that was right there. That was a 50-degree angle. So since I know that, on this triangle, you have this situation where you have a straight angle, and if one of them is 50 degrees, then you know this angle because it's a total of 180. A straight angle is 180. So since you have that, you have 180 minus 50, you know that this one is 130. So that is how I determine what this angle is. And we can just call it theta from now. So we have theta that we're going to use for this problem to 130 degrees. All right. So I'm going to erase these values. And I'm going to label my triangle so that I can use the law of cosines. So I'm going to say, we can just say A, B. Wait, we want the hypotenuse to be C, so we'll say A, B, C, and we'll say little c, little a, little b. And then put the law of cosines over here. And technically, I believe that you could use a law of sines in this problem. However, in this specific case, I believe that the law of cosines would be more efficient. It's just one formula to use. So we're going to use c squared equals a squared plus b squared minus 2ab times the cosine of c. Because we know angle C. So we'll say C equal 130 degrees. Anything else we know on this triangle? We have B. We have, so this is big C, so I'm drawing big. We have big C. And then we're looking for little c. We don't know angle A, but we know little a. Little a is 3.3, and little b is 11.2. And again, I like lists. It helps me stay organized. That way I can just plug in and makes it nice. And so I don't know what c is. So it's my variable. C squared equals, and we have a squared, so it's 3.3 squared plus 11.2 squared minus 2 times a, which is 3.3, and that is times b, which is 11.2, and that's all times the cosine of 130 degrees. Okay. All right, so now all we have to do is we're just gonna use a little bit of algebra and simplify all this. So I need my calculator for that. And also what you could do is in this step, if you really wanted to and you were in a hurry, you could go ahead and just square root everything in this step. And then you end up with c equals approximately, because the calculator will spit out an approximation. So we're going to skip that step. I'm going to go over here and just do it long ways. So 3.3 squared is 10.89. Plus 11.2 squared is 125.44. Minus 2 times times 3.3 times 11.2. And that's 73.92 times the cosine. And I'll just figure out what the cosine of 30 is. That is negative 0.6427876097. And really, if you get a negative in this step, you've done something wrong, because you cannot take a square root of a negative and get you'll get a distance that does not exist. It's an imaginary number, so right. But when you multiply this negative times this negative, you're going to get a positive. So if your cosine's negative, don't be alarmed. It's going to be negative if it's greater than 90 degrees. Cosine is negative in quadrant 2. All right, so I'm getting 10 plus, all right, so I'm getting 136.33 plus 47.51486.011. And I'm getting approximately 183 .8448601. And at this point, you would just take the square root of c. And it's giving me a value of approximately 13.55894023. And your problem might ask you, if you had something similar to this, it might say round to so many digits. We can just round whole numbers, and it is approximately 14 miles. Or 13.5 miles. So however you look at it. Okay. Again, you could have used law of sines to solve this problem. However, with law of sines, you would have had C. Since you don't have a relationship between the angle known and the one you're looking for, you might have to do it twice. So do I want to stop early? Because this was really fast. Sometimes you find the most, what's the word? You find the shortest path to the place that you're looking for. And in this case, it was law of cosines. So I might just celebrate that victory and stop early tonight and conserve my energy for tomorrow. So yeah, I think we'll go ahead and stop there. This is good. We accurately accomplished our goal, which was to find how far the ship is from its port. And it seemed like a pretty reasonable, approximately 13.6 miles. And units. And so that makes sense. It does, even though you don't have a right triangle. 11.2 plus 3.3. You can see that distance would be greater. So it makes sense in the context. All right. So I better stop there for tonight. And I just want to say, if you're watching my video, I greatly appreciate it. And if you would like to see more content, you're welcome to post in my chat something that you would like to see worked out. I am promoting group study with this live stream. So I really want to encourage a group to do math together. So if you have a question, please post in the chat and I will address it tomorrow. And if not, I will just try to find an example that is relevant that I think that might be useful for students. And again, happy Tuesday. I hope everyone's doing well. And I will see you again tomorrow, same time and same place. Bye for now.